Okay, we're going to pick up with number 9 and continue working through your final exam review. Here we're asked to find the reference angle for the given angle. Now, you have to keep in mind how angles are drawn. Remember, we have 0 degrees and it spins around until you come back and it's 360. This is 180. Every quadrant is 90 degrees. Okay. Now the angle that we're given is 204. 204 is in between 180 and 270. So we know our angle is falling somewhere in here. And so this little triangle represents our 204.3. The question is, how much is this little piece? So we need to take the difference of 204.3 and 180. So we need to type 204.3 minus 180. And that's going to give us our reference angle. So this little angle in here is 24.3. It's always going to be the large number minus the small, and you always, always, always draw it back to the x-axis. The other thing is reference angles are always less than 90. So C and B are not viable options to start with. Okay, use a calculator to find the function value to 4 decimal places. Well, we do not have a button on our calculator for cotangent. So we have to think about reciprocals. And if you think about your reciprocals, remember that sine is the reciprocal of cosecant, and cosine is the reciprocal of secant, and tangent is the reciprocal of cotangent. Now these work, basically you take the same thing and same equation, you swap your trig functions out, it's the same thing. So if I'm wanting cotangent, I can write this as 1 over tangent is what I'm getting at. Keep the angle the same. So whatever the angle is here, make sure the angle is there. I have a button now for tangent. So I can type in, please make sure your calculator is in degrees, by the way, 1 divided by tangent 22.5. And that's going to give me 2.4142. It's a perfect match for option D. All right, let's move on. Use a calculator to give the approximate value in degrees. So I am told that sine of some angle is 0.4848. Okay, now we basically need to do the inverse sine. Remember, to solve any kind of equation, you have to use inverse operations. So technically what you're doing is you're doing the inverse sine of this side, and you're doing the inverse sine of this side. And these undo each other. That's how you're going to solve the equation. So we need to access this part on your calculator. And if you get to looking, that's the second button. So every time you look for an angle, you need to press the second button. So you're going to press second sine, and you'll get that little sign with the little -1 up there. It looks like a power. It just means inverse sine. And then type 0.4848. And it will tell you 28.9999, and it keeps on going. So we're going to round this thing to 29 degrees. Okay, now we have to draw the picture. Now, to let you know to start with, on your test, you will not have these little things attached to your angles. We did not do this part in our course. So what we're going to do is we're going to replace this with the 28. But I need you to remember, these answer options are not going to be exact because we just changed what the angle was. Our answer is going to be a little bit larger because we rounded up, basically. Okay? So, here we go. From a boat on a lake. So we've got a lake. Here's my water, and here's my boat. From this boat on a lake, the angle of elevation to the top of a cliff. So you're looking over to the side, and there's your cliff. And there we go. Angle of elevation is what's angling up. We're going to put 28 degrees here. And it says if the base of the cliff is 2,641 feet from the boat. So that's talking about horizontal distance. So down here, and that is in feet. How high is the cliff in feet? The good news is we match, okay? So we don't have to convert anything. We just need to solve the problem. Again, our answers are not going to match spot on, so we're not going to worry with matching our answers. But we do need to figure out which trig function to use. From this angle, this is the opposite side, and this is the adjacent side. So that's going to be tangent of my angle is equal the opposite side, which is x, over the adjacent side, which is 2641. Now remember, the way we set this up, we always turned everything into a proportion. So you're going to take your trig value, you're going to place it over 1. So now we have a fraction equals a fraction, and you can cross multiply. So that's x equals 2641 tangent of 28. So if I type that in, 2641 tangent 28, I'm going to get 1404, okay? We're just going to leave it like that and not try to figure out which one matches because we changed our angle, okay? On number 13, it says, on a sunny day, a flagpole, so we got a flag, in its shadow, so there's the shadow, form a right triangle. Okay, so we're going to assume that we have a little connection here. So if the hypotenuse is 35 meters long and the shadow is 28 meters long, you know, shadows are on the ground, how tall is the flagpole? Now the question is, do you need trig? No, you basically went back to 7th grade or 8th grade, wherever you learned Pythagorean theorem. That's all you need. You need to know that the legs squared and summed up is equal to the square of the hypotenuse. So if we work this thing out, we've got 28 squared is 784, and 35 squared is 1225. I'm going to subtract my 784, and when I do that, I'm going to come up with 441, I do believe. Let me just make sure. I do, and then I've got to come in, and we're going to do the square root, the inverse operation, remember, to untie things. That gives us a perfect 21 meters. There we go, option D. All right, let's move on. We're going to match each trig function with the graph. Keep in mind, the easy way to do this is remember that sine always starts at 0. Okay, and then cosine always starts at the amplitude. Okay, now remember the amplitude is the coefficient, so the number out front. So let's just look at the ones that have sine, number 1 or number 3. Number 1, there's a 1 in front of sine, you know, but he's supposed to start at 0. That means when x is, we're looking at this line right here, you know, what is the y value? What on that line? So that's not happening at A. On option A, we're starting at 1, so he's out. Option B, he's starting at 0. We're doing good. But the next place it goes is -1. So is that going to be number 1 or number 3? We're going to say number 3 because that's what the amplitude is. That's a -1 there. So this is number 3 and B match. Okay, so let's keep looking. There's got to be somebody else. Here we go. C goes through 0, and the very next place he goes is +1. So that is option 1. 1 and C match. Now, cosine, remember, he's going to start at the amplitude, and then he's going to go to 0. So number 2 says amplitude is 1. Which one starts at +1? Well, that's A. Which one starts at a -1? Right here. That's D. So that one's number 4. Alrighty. So go and graph this function. We just talked about cosine. Cosine always starts at the amplitude. Amplitude is right here. We do not have any kind of vertical translation. Remember, vertical translations look like this. We had a number out front, and then it would be something like that. We don't have this extra number. So nobody has moved your graph. You see that option C and D, this curve has been pushed down. And on option D, this curve has been pulled up. So these are out. We don't have that going on. We need to look at A and B. They're both centered on the x-axis. We need to see which one goes up to -2 and, down to -2 and up to +2. And that's going to be A. That's -2 there. There's +2 there. And it's perfect. He's starting at -2, and then he's doing exactly what he should. This looks like a sine curve. So he's out. Got to be A. Okay, so number 16 says find the amplitude. We've been talking several times now. Amplitude is the coefficient of your trig function. So it's just 4. It's a vocab question. Okay, so it says find sine of s if cosine of s is 2/3, and we know that s is in quadrant 4. We have to take all of your clues and investigate. First of all, quadrant 4. 1, 2, 3, 4. So draw a triangle in quadrant 4. Okay? We need to label the sides that we know. Cosine is always adjacent over hypotenuse. So the adjacent side is 2, the hypotenuse is 3. Now we need to find this other side. So he's missing. This does not meet the requirements for one of our special right triangles. If you remember the special right triangles, if it's 45 degrees, that's when you had 1, 1, square root of 2. If you had a 30, 60, 90, if this was the 30-degree angle, this would be 1, square root of 3, and 2. So these numbers do not work. If that had been a little bit different, so they're trying to jerk you around a little bit, but it's not quite what you need for a 30, 60, 90. So we got to scoot over, and we're going to do 2 squared plus I don't know squared equals 3 squared. So our legs are together, and hypotenuse is on the other side. We have 4 plus x squared equals 9. Okay, subtract your 4 on both sides. 9 minus 4 is 5. Square root of both sides, because you have to do the inverse. That's going to be square root of 5. Well, keep in mind, this is going down. So since he's going down, you have to put negative on him. The other option for negatives is, remember, if you go left. So if we were going over here into quadrant 2 or quadrant 3, and we were going this way, we would need a negative. So going left and going down, you have to put your negative on there for direction. Now let's build the one that they ask. Sine is some old hippie. So some old hippie, that is opposite over hypotenuse. Opposite is negative square root of 5. Hypotenuse is 3. It is a perfect match. You don't have to do anything to that. There's nothing wrong with having a square root in the top. Okay, let's see. I think we can squeeze one more in. Again, use your clues. Quadrant 2. Quadrant 2, we need a triangle. Okay, sine is opposite over hypotenuse. Okay, opposite is 3 then. Hypotenuse is 4. We, again, need to find the other side. It's not a special case, so we got to say 3 squared plus I don't know squared equals 4 squared. So we have 9 plus x squared equals 16. You're going to subtract 9 on both sides. 16 minus 9 is going to be the square root of 7. Now, oh, excuse me, it's just 7. I jumped ahead, didn't I? And then you do the square root, and you end up with square root of 7. But when you go to place it in your triangle, keep in mind, we're going to the left. This is where the negative numbers are going. You're having to keep direction in mind, okay? So it's negative square root of 7. We want to define tangent. Tangent is always opposite over adjacent. So our opposite side is 3. Our adjacent side is negative square root of 7. You cannot leave a square root in the bottom, so you have to rationalize. Remember, negatives can just float to the top. That's okay. So the negative goes up there and joins the 3. You can't multiply the 3 and the 7 together because outside numbers and inside numbers don't play together. And then square root of 7 times square root of 7 is just 7. So it's a perfect match for option D. Okay? So that wraps up this section. See you in the next one.